Okay, and welcome to our quadratic inequality review. And I think y'all are going to find this to be incredibly simple. So, on each one of these problems, I just have a simple number line that has, just various different starting points. And we're going to look at specific inequalities on a one-dimensional scale. So here we have x is less than or equal to positive 7. So what do we want to do? Well, we always want to go with this number here, 7. And I always want y'all to go circle that hash mark and or the number. Now notice it's less than or equal to. Whenever we have an equal to symbol, that line on the bottom, we're always going to shade that in. That means that 7 is also potentially a solution. It's included in all the solutions. Now when x is less than, that means that we're shading everything to the left. So if I were to ask you what is a true value, well, it's literally anything to the left of 7. So that could be positive 3, it could be 0, it could be negative 4, it could be negative 7. Let's just say, negative 1. Why not? That's a true value. Where would you find a false value? Well, that's anything to the right that will be false. So for instance, the first false number we see is 8. It's not included in all the solutions. Okay, let's take a look at example 2. Now example 2 is what we call a conjunction of inequalities. Why? Because it has two separate sets of, this is called a disjunction, my apologies. It's a disjunction of inequalities, and we have two separate sets. So one, we always start with the number we see, negative 3, and we want to circle it. Now notice this is less than or equal to, it has the line, so we're going to shade. We're going to say, you know what, negative 3 is most certainly included. Now it's x is less than or equal to, we're going to shade everything to the left. Remember, and this goes towards negative infinity. Okay. Now we also see that x is greater than 1.5. So I come over here to 1.5. I'm going to circle halfway in between 1 and 2, 1.5. And it's greater than, but it's not greater than or equal to. There's no equal to symbol. There's no line underneath. So we leave the circle open, unshaded, and since it's greater than, we will shade everything going to the right. Now, everything to the right of 1.5 is a solution, but guess what? 1.5 is not a solution. So anything from here to here is not a solution. It won't work. Literally anything else will. We could say, negative 5, negative 4, negative 6, negative 7, negative 8. All of those are true values. 2, 3, 4, 5, every number in between. Let's just say a decimal. 5.56 will clearly be a true number or solution. Now let's take a look at example 3. Example 3 gives us negative 3.5 is less than x is less than or equal to 5. Wait a second. Do y'all see how the x here is in between the two numbers? This is what we call a conjunction of solutions. So you have my apologies. So let's go to negative 3.5 and let's circle negative 3.5. Now whenever we have a conjunction of solutions, I'm going to stop right there. I'm just going to circle it. And notice I don't shade it in because it's less than or equal to, it's less than, it's not less than or equal to. But how about 5? I come over here, I circle 5, and this one actually is a less than or equal to symbol, so I will shade it in. Now, when we have set this up so x is in between the two numbers, we are not using the word and, we have this conjunction of solutions. We're actually going to shade everything in between these two values. So we're saying that all of our solutions have to lie in between negative 3.5 and positive 5. And the only exclusion is we know that our solution can actually not contain negative 3.5. That is not a solution. Or you could have literally chosen any other value outside of our shaded region. Over here for a true value, we could choose negative 3, negative 2, negative 1, 0, 1. We could choose 1.5, 2.5, any one of those. Why don't we do 3.47 just to kind of switch it up. All right, let's move on. I've got two more examples to do real quick. Okay, here we have example number 4, where we have another disjunction. We have x is greater than 3. So let's see. So I find positive 3. And notice it's greater than, so we leave it open. And we go find negative 4. And since this one is less than or equal to, well, of course, we're going to shade it in. Now, wait a second. x is greater than 3, that means we'll shade everything that is to the right, or every value larger than 3. And, oh, my bad, guys, there should be x right there. X is less than or equal to -4, we'll shade everything here to the left. So what would be an example of a true value? Well, let's do something very close to being not a true value. Anything to the right of 3.0 is a true value. We could even say 3.04. Just because it's slightly greater than 3, it's definitely included. What would be an example of a false value? Well, once again, let's just choose, let's choose 0. Okay, clearly it's not in the shaded region. It's not a solution. Okay, let's take a look at number 5. We have x is less than 2, and x is greater than or equal to 2. Whoa, wait a second. Okay, so I come over here to +2, and I circle it for this. And let's actually do these one at a time. X is less than 2. Well, I'm going to shade everything over here. Okay. And then wait, x is greater than or equal to. So now we're actually going to shade it, and we're going to shade everything over here to the right. What would be our true value? How would we write this? Well, we'll just say this. It is all real solutions. All real solutions. What's our false value? In A. I guess, since we've started talking about imaginary numbers, let's say this. Let's say our false value would be all complex numbers. Because now we're going to get into a higher level of mathematics. We have more options in distinguishing numbers here. Okay, and remember, guys, a complex number is just a combination of an imaginary part and a real part of a number. All right, good luck.